Alright, so today we are going to be building facade editor. So if you have followed the very first live stream, I was working on the procedural walls using spline. We are going to be restructuring this, and of course these all like fences and all are from, and the stair, these are from previous splines, previous episodes, and if you have not watched that, please go ahead and watch them. And we are going to be starting now with the facade building. The first thing that we need is going to be this walls, and to develop a facade you need to procedurally to develop a procedural facade you need to be able to add custom doors and windows anywhere inside the wall based on parameters. I mean, you don't have to manually do anything. Most of them are parameters with the flexibility to control them manually or override them manually, because when you're building something procedurally you also need to ensure that even the artists who are not going to uh, directly modify your code, they also need to be able to tweak to their satisfaction, because there may be requirements for manual adjustments and all. So you need to ensure that it can support manual overrides as well. All right, so let's begin. So let's look into the code. Here we had the source blind actor. If you have not followed the previous live streams, let me just quickly explain. The source blind actor is just responsible for creating a spline that you can directly drag into a level and add points on that spline. And your any actor that is going to use a spline is going to be derived from the source spline actor. So previously the mistake I was making in the very first live stream was that I was keeping them as two separate actors, one for the spline and one for the wall. And that was causing a lot of issue in terms of synchronization, and then I was also facing these rotation issues. So having this into a single spline, I mean into a single actor, may prevent that. So what we are going to do now is, so we had this wall actor. This wall actor was actually taking the source plane actor as the uh, source and building the wall on top of this. So first thing we are going to do is remove this. I mean, I just need to use the derivative from this, like it is going to be a child of the source line. And then I have, this is fine, wall mesh. Let's move on to the CPP version of this and check out how this is working. We have to fix all these issues. In this case, I don't need this because this is in the same actor, so I don't need to pass on any delegates for this. I will also need to remove this as well. And yes, I also need to remove this. I don't need this anymore. So now we are left with, yeah. So create static meshes is where the code where the wall mesh is been created. So I don't need this. I only need to have this. So yes, I will replace this with spline component, which we have already defined in our source spline actor. If you see over here, all right. So now this, I think I don't need this, but I will need to call this somewhere. That somewhere is going to be inside the constructor script over here. Here I need this. I would not need to use these delegates at all. Yeah, the create static message is already function is already available over here. So I'm not going to add this all over again. So here also you can see, yeah, we will figure out what to do with this over here later. For now, let's just remove this one and only keep this. And we also don't need to do this all over again. Anyway, it's this is going to be irrelevant for now because if entire thing is already going to be called inside the construction. So I think this will prevent any compile issues. So let's just compile and check. Right. Okay, I think I need to close and reopen this. So let's do that. Right, the level has opened. So this wall is obviously gone. You have to, I think, modify this, but the spline is at least here. So this is the source spline actor. We don't need to use this anymore. We will delete this and instead we are going to use this one, procedural wall, because this already contains this line. As you can see over here, right now we can drag this line. So I don't want curvature over here. So I will, there is some, yeah, is curved. I will just check this off. Now this is straight line. Okay. Too much specularity actually. So I will just add this post process volume and extreme. Remove the bloom first of all. Set to 0. You can see how it changes. And then auto exposure min EV100 and max EV100. So that it's feasible because otherwise too much speculation is coming. Keep it to 1 and 1. And now I can increase the directional light a bit. Yes. So also I can change the material for the floor. Yeah, it's much better. It's much, yeah, now it is visible properly. I think I can increase this further. All right, so yeah, now we need to build our wall. So let's select the, oh, there are two of these. Okay, delete this. Now we need to have the source made. It's going to be our standard cube. Any cube will do basically. There is the offset that we are going to figure out. If this is more than offset is coming, yes, or else if this is less offset is not there. Let's check out why the offset is coming from here. Here, getting the number spline point and out location and in location and updating. Let's remove the unnecessary variables first. Okay, here I'm updating it based on the start location and also look at rotation. Okay, let's see over here. Let's just use relative location instead. See what happens over here. Here also I will use instead local. It's here. Okay, here I will change this to keep relative transform. The rotation has some issue. Let's just remove the relative location for now and just check how this works. Okay, yes. Now they are at least fixed with the location. Now from here, that was the location is actually now fine because they are now at the same point. The issue with the center is because this wall pivoted at center, and also you can see some of part is going ground, and that is the reason I need to use the dimension but properly. So here I think we need to also rotate the vector, and then we can just use. So this is fine. Given string location equal to 10. Component location gives center equal to gives center matrix 10. So over here, yeah, I have made a library function. Let's use that because this is the same thing I'm doing, so it doesn't make sense that I'm doing it twice. And just let me check where else I've used it. I have used it also for fence generation. If you have followed that, you know. So let me just use this over here instead. If vector desired location equal to no, not like so. Where it is here. So initially desired location is the location like this, and when you start location, then this is going to be minus rotation dot rotate vectors, and then here I am going to use this. This is going to be we didn't change any code, we just made this simpler. Now we have to see what's the issue. What if I don't rotate this? Let's just give this relative rotation for now. But anyway, I will just comment it out and see how this works. Now there is absolutely no rotation, and they are mostly located at the relative center. In this case, I also have to remove this and directly add this. Okay, now they are not moving. So the issue with moving the rotation and the rotation, I think it has to be what I was doing wrong over here is putting the fine. So the rotation needs also to be adjusted with the relative location, like how I was doing over here, because otherwise it is going to be rotated around its center. But that's still going to be fine. Okay, let's just add the rotation back. Rotation, rotate picture. Oh yes, yes, now it works perfectly. Yes, it is perfect. Yes, it is working perfectly now. What was wrong actually over here? Because I was doing this previously. If I add this before, okay, now yeah, I think even if I add this before this, it is because rotation when it is changing its rotation before that, and so if I do this, yeah, now so this needs to be it doesn't matter if it is before things setting the location, but this needs to be relative rotation needs to be before you are calculating this part because this also the bounce also calculate when you are doing this bounce thing. It also is going to calculate the rot. I mean, it's going to take into account the rotation factor because when you are getting this box and center, then the rotation components is also shifting. So that's why this needs to be done first, and then we are actually rotating the mesh, and then we are setting the location. I mean, this can be after also, it doesn't matter. But this calculation needs to be before setting the location and the rotation, right? Now I will just get back to this. Uh, so now this is a working, I mean, procedural wall, right? Very easy to implement. If you see, if I extend the spline further, you can see I can easily build whole wall. If I do this closed loop, oh, the spline got closed, but the this also needs to work now. Okay. So what I can do is I can set the condition that if this is closed here, so here equal to if if I equal to num point minus 1, right? If not closed, no, what is the okay, this is a part of the spline itself. Yeah, this variable is not a variable set by me, but this is the variable that is part of the spline. So what I can check is spline component, sorry, spline component is closed loop. If it is not true, then I will simply break the function because anyway it's the end of the function, and if it is not closed, then I don't need to continue further because I don't want to create additional mesh. But if it is closed loop, then 32 ends in date equal to 0. Okay? And Here, ending text is going to be I plus 1. By default, it is 0, but when the I is very large, then when the I is not the last point, then it will be incrementing. Anyway, I was getting the next point, and next point is always one incrementing. So I can do something like this. Okay, instead of adding an additional variable, I'll just check the close loop equal to line a close loop. I don't need to check this inside for loop because this is going to have a single value. So I'll just add it over here, and if it is not a closed loop, then it's going to break. And if it is closed loop, then end location is going to be 0. Yeah, you can do something like this. And if it's not num points minus 1, then this is simply going to be valid. All right. Or we can also include an ending text value like I was doing before. Help index equal to 0, index equal to I plus 1. This is going to be index. Okay. Keep it, or I don't need another L because anyway it's going to break if it is not closed loop. Or I can just put it after. It's the same thing. Okay. Now let's check this. Yes, so when it is closed loop, so the entire wall is being generated. And if it is not closed, let's check the form and see, right? I'll keep this off by default. I will add the remaining line later, but first let's work with what we have, and which is two walls currently, because our purpose is also going to be designing the packet. Oh, when I press undo, um, if I click on undo, then additional wall is going to be generated. This is not good. We need to clear the previous meshes also, and new meshes are created. It is being done. I think I need to handle the undo ready situation also. Not here, over here. Oh, here it is already there. Weird. We need to solve this bug. Copy everything and head to our friend GPT. and explain it the problem. When I am pressing undo, the previous wall persists and new mesh gets created. But I'm already doing this. I mean, over here. You can do also check for any child mesh component and here any other mesh component. We are finding. Yes, so if I press undo, yeah, perfect. It's finding for any processing mesh that is not a part of the static mesh also and clearing them anyway. Now, how do I extend this to create facade? So let's say there are multiple ways of doing this. I want to have an array of doors, like every X distance there can be doors spaced and then we can customize them. Or we can have we, like we can add a single door or window and we can adjust its position along the surface of the wall. Okay, To start with, let's begin by randomizing like between the minimum and maximum number of doors, and we will arrange them over here over the surface. Let's see. Uh, Better to use data asset for this. So what I'm going to do, I'm going to create a folder called data assets, and over here I'm going to create a class called classes data asset, new data asset. It's going to be named as facade config or facade extension asset. Sounds better. And now I'm going to do one more thing. I want to keep the procedural wall untouched, and I will create another class that is derived from the procedural wall, and I will name this as procedural facade. It looks better because people may want to use procedural wall but not procedural facade. Then they don't need to be bothered with that. So just add a class a procedural wall actor derived from will be named as procedural facade. Procedural facade. Yes. Okay. Well, what price I include? And it's a weird curve. Okay, let's just close this and try and compile and see if it works. Yeah, build is fine. Let's just try to add something and see if there is an issue with compiler. Okay, yes, it is working fine, but only this is intelligence may not be working properly. Load everything. Let's just uh, regenerate the project file. It's fine. All right. So, yeah, after regenerating the project that is now working, so we can go back to over here, and yes, I was making this data set. Here, I'm going to add some new properties. Alright, so my door and window configuration is done. So this can be, for example, like door knobs, door handles, door locks, or any other things, door hinges that you want to add. Okay, and can also add properties like offset and so yes, it is clearly filtered by default. It has 111 obviously. You can also change that. And also parts can be, they can by default located at horizontally at left, center, right, or vertically at top and bottom, top, center, and bottom. I need a enum. Part can be located by default in horizontal left, center, right, and same with vertical. Implement that. It's going to be interesting. So by default, I mean, I can also set that by relative offset, but that is going to be too much hard work. So by default, we are going to be fixing if the part should be located at left horizontally or top vertically, something like that. Okay, we need these two variables. Now we are going to be asking GPT to, so yes, first we need to add this config variable over here. All right. So you cannot just create doors and windows before you create holes in the respective area. So, so the parent wall actor is just creating, just creating, create walls without holes. So how will you add walls? So here I want to specify that I have done something about 8 years, 7, 8 years ago. So you can also find in one of the oldest video of in my channel. So in there, I was actually the approach I was doing at that point of time. There was no AI or ChatGPT. It was all me. So the approach I was using is dividing the mesh into further meshes. And let's say I have a door in the center of the wall. So I am actually adding not one but four meshes for the wall. One that is starting from the source and ending at the towards the starting point of the door. Another is and starting from the end point of the door and ending to going towards the either end or towards the next point of the door. Another is for the top part, the if there is a between gap between the door and the obviously the in topmost portion of the wall, that part is going to be created by another mesh. And if the door has some bottom offset, and specifically for windows when there is obviously a bottom offset, then the bottom part is also created. That's how I was actually building. But I let's see what ChatGPT's approach is going to be in this case. Add holes in our wall. It gave none of the well, it gave none of the solutions that I provided. It gave completely different set of solution. I know all this because custom mesh generation is something that I don't want to do. Since your wall can have a custom design that you may want to develop externally, it's not possible with a custom mesh generation, and then you can bring that and add it over here. So I also want to ensure that that is also possible. Boolean operations meshes, we need to convert the mesh into procedural geometry, and again the Boolean operations is not going to be very straightforward and requires a lot of custom work. This is not, I mean, this is going to be too complex given that there can be an array of multiple doors and material transparency. You cannot just pass the array of points in the material. So that is going to be extremely difficult and, I mean, impractical to implement. Think ChatGPT cannot provide the solution, so we have to go with our approach and we have to explain no, it doesn't. Makes sense because the position and number of doors and windows are going to be dynamic and user defined. Yes, now it is making sense. Now it finally told us that it is practical to create segmentation of the walls. Yeah, this is exactly what I did several years ago. So in the original code, in the original code, we were creating the static mesh along the spline. So we need to alter this a bit and have to obviously we have to get each and every spline points, but then inside each of them we need to check how many first how check we need to check how many number of doors are required, and that calculation is going to come from here. From here, mean doors and max doors, how many mean doors and how many max doors are required. Here we are going to be doing our thing. So let's first here we need to also add a construction script, or we can what we can do is we can simply virtual void pre-static mesh. Here we can simply manipulate this instead. Running start config. This I don't want instead because I don't want to already create the existing facade. I'll just delete this and I have to manipulate this myself. So here first I'm going to need doors and max doors. And then let's say I have three walls. So we are going to be dividing. mm, First, calculate how many total doors and windows are needed, because let's say if there are five doors and two spline actors, no, two spline and three spline points, then of course two walls are going to be created depending on if the spline is closely as seen below. And here I will just pass on this function over here. But in the case of facade, the number of doors and windows are going to be randomly determined based on min max values by for each of the line point pair. So calculate the, that first, and then we will construct the position of the wall segments accordingly. Sorry, I need to implement over here. So what I will do is, if not facade config, then I will simply create and we'll call the super function. It will create the wall simply, alright? And so here I'm going to clear the static mesh component. Here it's already been cleared, so I don't need to be bothered with that. So start location and location, I think it's fine. Hey, I think it is on track. So it is giving segment config and then number of points. It's calculating the values based on random range. And then we need to create this function. Since it's passing the struct, so it's better if we add the struct as a global variable outside this. Also, we need to yeah, create the declaration. Now I will ask it to implement. Let's see if this is right or wrong. When length is fitting the yes, this is fine. I think it also needs to pass the door config, facade config basically. Yeah, it's already there also. I mean, it's the part of the function. So door config of in left side. Take the max side. Same with the window. We here math random range. This and this. Oh, it is door vector 2D actually. So I will just use vector 2D. Yeah, VRAM. We have to do VRAM. No, no, no. Door size will be between similar for Windows. Let's do this. Door width So it's fine, door height is fine. Same with window width and height. Implement. Alright, so now let's copy this here and check. This will be when, no, sorry, this will be facade complete, door complete, the door mesh, sorry, door mesh. Window complete, door, window mesh. Now we need to, now we need to implement this wall segment. The wall segment is actually going to be mesh. So wall, I think wall mesh. Let's just check quickly. So let's name this as wall mesh. Okay, this is done. But currently, we are also reached the end of today's sessions because it's already 12 p.m. and we will continue the session day after tomorrow. Tomorrow, it's not possible for me to conduct the session morning. I will not be available. So please join me day after tomorrow and subscribe to my channel so that I can notify you whenever there is an update to the new live stream link. All right, so